Welcome to the Nokia Optical Networking Learning Essentials video series from the Nokia Optical Network Certification Program, an end-to-end learning program supporting Nokia 1830 PSS, VWM, and NFM-T based networks. Today, we'll take a look at traffic survivability through GMPLS SBR. This video has been created based on the Nokia GMPLS Controlled Optical Networks course. In this video, I'll explain the Source Based Restoration or SBR mechanism implemented at L0, identify node architectures for GMPLS L0 restoration, and describe how to configure this through NFM-T. In GMPLS networks, there is a defined management hierarchy between the Network Management System, or NMS, the control plane running over the nodes, and the transport data plane. This centralized manager, implemented through NFM-T in our case, provides an abstraction layer from the network resources for the operators. On the other hand, the control plane, that runs on each GMPLS node, deals with internal equipment mechanisms so that trails and services can be created by using local resources. With the introduction of recent ROADM architectures, the network elements can now reconfigure themselves in real time. CD ROADM architectures, for instance, are colorless and directionless. This means that optical transponders can be optically switched to any degree and can be retuned to a different channel depending on different needs, without requiring physical refibering or manual changes in the configuration. This architecture type gives networks a high level of freedom to restore traffic. In this video, we will configure a GMPLS L0 restorable SBR trail. This restoration mechanism calculates backup nodes upon failure using non-reserved resources available in the network. SBR allows for multiple failure recovery iterations because the restoration process is repeated for successive failures. In this slide, we can see the macro steps to provision an optical network through NFM-T so that it can host restorable traffic. In our example, the network commissioning steps have already been completed and the network is ready to transport trails and services. We're about to create a trail over 130 SCX10 transponders between the termination nodes depicted on the slide. Let's move to the NFM-T GUI for the next steps. First, let's verify that the network is ready to support traffic. Go to the Network Protection Architecture, or NPA list. Operate NPAs. Now, select the item Lab3 NPA, which is the NPA to which this network belongs. Check that all ASIN links have been unlocked by selecting the NPA Links tab. In this network setup, we have 5 ASIN-capable links, thus 5 OMS links are present within the selected NPA and they are named after their related physical connections, or Optical Transport Section OTS links. Now that we are sure that the network commission has been properly completed, we can provision a 100 GB SBR trail. To do that, let's open the Trail Creation Wizard by clicking on Deploy, New Service Infrastructure Connection menu. Then, under the Best Practices template, locate the ODUK with L0 restoration item. Right-click it and select Deploy. A new window will appear. Do the following on the wizard. Set the rate equal to ODU4, as this is the rate available for the selected transponder. Select the termination node's endports. Provide a meaningful label in the connection name field. Tick the ASIN routed checkbox and verify that the ASIN restoration type is SBR. Verify that the ASIN parameters and priorities are suitable for the trail being created. In the Routing Constraints panel, look for the desired path to be taken by the trail, include it with the assigned constraints, and select a frequency. Finally, deploy the trail. Now that the trail has been created, we can verify that it has been added to the NPA and check the nominal and current routes. To do that, in the ASIN SNCs tab within the NPA menu, left-click on the service and see the details. A new window will open. From there, go to the Routes tab. In the panel on the left, we can see the nominal route, which is the route configured initially, at setup time. In the panel on the right, we can see the current route, which is the actual route taken by the trail. In case no failures are present, nominal and current routes are the same. So to recap, we created a 100 GB trail over a network made of CD ROADM nodes. Their architecture, based on colorless and directionless components, allows traffic to be diverted when a failure occurs. GMPLS is enabled on these nodes, and the restoration mechanism used in our exercise is SBR, which calculates backup routes upon failure using non-reserved resources available in the network. Finally, to deploy such a restorable trail through NFM-T, some network resources should be assigned in advance to the related NPA. This is part of the network commissioning phase. Then, by using a specific template and by flagging all relevant ASIN-related checkboxes, the new trail can be routed and managed by the control plane instances available on all nodes. Thanks for watching, and look for more videos in our Optical Networking Learning Essentials series. Whether your goal is to enhance your optical networking skills or demonstrate your expertise through one of our 4 industry-recognized certifications, the Optical Network Certification Program is here to get you, your career, and your organization on the right path. Our program features 9 instructor-led courses developed by our team of subject matter experts using industry best practices, use case-driven examples, and hands-on labs. Learn more and get started today by visiting our website. Thank you.